Welcome to the video tutorials of mechanisms by mekanizmalar. We all learned in high school physics how a projectile moves in an airless environment. This animation will refresh our knowledge on this subject and prepare us for our next animation focused on this subject. In this animation there are two cannons firing projectiles. The red cannon is operating within 45 to 90 angle ranges, while the blue cannon is operating between 0 to 45 angle ranges. We have the ability to change the initial projectile velocity and adjust the cannon angles in the ranges we described earlier. Also, we can stop the animation by selecting the stop checkbox or reset the animation by pressing the reset button shown here. The trajectory of a projectile is calculated by using parametric equations of x and y component of the projectile shown here. The initial value of x is assumed to be 0 since the position of our cannon is not changing. On the other hand, the value of y can be adjusted between 0 and 200 meters inclusive by putting our cannons on a hill. When the total firing angles of the red and blue cannons are 90, they hit the same point in the horizontal plane. However, the blue projectile will reach its target much faster than the red projectile. On the other hand, if there is a small hill between the cannon and the target, the blue projectile may hit the slope rather than the target. To reach to the target we should use the red projectile because it reaches a higher altitude. The longest range a projectile can be reached when the cannon fires its projectile at a 45-degree angle is shown here. Not a single artilleryman in their right mind will fire a cannon at a 90-degree angle because, as you can see here, that would be his or her last fire of a cannon. If the red and blue cannons are fired from a hill, their projectiles will go further. However, even if the total angle of the red and blue cannon is 90 degrees, they will not hit the same point. The projectiles will pass from the same point on the horizontal line, passing through the cannon locations shown here. I will put actual animation into my web page where you can play with it, or you can compare your solutions with info found in this animation. When we fire the projectiles horizontally from a hill with increased exit velocity, they will go further. Let's show this distance for 100, 200, 300, and 400 meters per second projectiles velocities. As you can see, distance are 638 for the velocity 100. $1,276 for the velocity 200. $1,914 for the velocity 300. And 2,552 meters the velocity 400. Newton believed that there is a velocity that will enable the projectile to stay in a circular path on a perfect circular planet without an atmosphere. This velocity is called orbital velocity and is the subject of my next animation. Please note that red numbers show current position of a red projectile and the time takes to reach that point, while blue numbers show the current position of blue projectile. Also note that black numbers can be used to find position of a projectile in a given point on trajectory. Thank you for taking the time to watch our video. If you enjoyed this video and found it to be useful, please subscribe to my channel and hit the like button. We appreciate your support.